All right, we are going live. Let me know if you guys can hear me. We are World Quant Unit 1, Week 6, I believe. Office hours number 24. All right, so do let me know if you guys can hear me so I know that I am going through. All right, Tom and Timur are letting me know that they can hear me. Hello, and thank you for that confirmation. I see Naya is here. All right, welcome back to Office Hours. Let's go ahead and start get things rolling. And one of the things I discovered was that I cannot get access to my pod right now. Looks like I try to access my pod, and well, this is what I get. So. Looks like something is going wrong with my pod. Perhaps high usage going on right now, which is sort of a good thing. So the bad thing is, well, I cannot pick up where I left off exactly. But the good thing is that I have access to another pod that I can also work onto. So I think we are nearing the end of Q6 of the DW mini project, but I'm unable to pick up where I left off. But I do have various things up on the agenda as we transition to work on something that is not the mini project. So a couple prereq, lay the ground floor, our foundation, as we move on to different topics in data science, like working in the shell and the command line and version control with Git. So let me take a look at what are people saying in the chat. So I see that Shakiba is here. Hello, Shakiba. Thank Timur for the confirmation. Dinaloa is here. Hello, Lyndon Smith. Hello, everyone. Joseph is here. Welcome, Joseph. Naya has a question, so go for it. Let me know your question, and we could get that answered, hopefully. All right. Yes, so they're reviewing Tuesday's office hours, script anomalies. Yeah, that one I struggled with. For some reason, I was not getting the correct answer. I was doing a lot of things on the side, showing you different things about pandas, so I think I lost track of... I must have been doing something wrong in the code, and it was just... I had to kind of start from scratch is what I did towards the end there. But could you please explain the argument in str contains? I found that the vertical line is a regex character, but I don't know what the R means. Oh yeah, so the R there is a raw string. It's a raw string. So if I go into, looks like this is still suffering. So let me go into this other special admin account that I have access to. I'm going to go up into here. I'm going to open up data course. Let's go in a new Python 3 notebook. I see Daniel is here. Oh, hello, Daniel. Let me rename this to Office Hours. November 5th, 2020. So we have, let's say, my string, and I say, hello there. And I can say, print my string. It's print, not whatever I spelled. And notice I have a new line character. Notice I have a new line character right there. So hello there. So the /n, Python C /n says, you don't literally mean a /n. What you mean is a new line character. /t. /t stands for a tab character. So Python C says, you mean you want a tab. You want a tab right there. These are meta characters. However, what if we literally mean I want a /n, or I literally mean a /t? I don't want Python to interpret that as a new line character or tab character respectively. I literally mean a /n, and I literally mean a /t. Well, one solution is that you escape it, so you put an additional slash, and now Python says, you literally mean a /n, you literally mean a /t. So that's how I can fix this problem. But you can imagine if I have a very large string, and I have perhaps a lot of special characters, and I don't want to go through and escape all those special characters because I might miss one. It's a bit tedious. I have a solution to it, but it's a bit tedious. So what if I told Python right off at the bat when I create my string that what I have is called a raw string. So any of those /character, that's what I literally mean. So I can say my string, have an R right in front, and say hello /n, there, hi. And print my string. And notice I didn't have to escape those special characters because Python saw the R, says, that's a raw string. You literally mean what you're going to write out next. And the reason why we do this when we work with regular expressions, which is something I don't think we have introduced in this course, but is a great topic for office hours. It serves as a great office hours topic. Regular expressions. Is when we work with regular expressions, we often deal with special characters. We often deal with, let's say, /w plus and /d plus, things like that we don't want Python to interpret to mean something. And I think let's just try it out. I wonder if curious to see if /d means anything special. Means a /d. I think a /r is, yeah, /w. We often have special characters when we work with regular expression, and we don't want Python to interpret it as something. So we use a raw string. Hey, Python, I literally mean this. So it's sort of a good practice that when we have regular expression strings in Python, that we make them as raw strings for that fact. Do let me know if that answered your question. Let other people who are joining us, let me know anything you want me to throw up on the agenda. One of the things that is happening right now is I cannot... Did I get access to my pod now? It's still can't get access to my pod right now. But so let's see. There are a couple things I do want to talk about today. And let me go ahead and try to shut down my pod. Maybe that might help out. Okay. All right, glad that helped out. Let me know anything else want to bring up today in office hours. So while I am continually trying to get my pod to come back up so I can pick it up where we left off and wrapping up the last mini project, I'm going to go ahead and talk about some additional topics that are great when we work on a project. One of those is the command line and the shell, and then we'll transition and start talking about version control. Okay, so let's go ahead and talk about the command line. So you can think of a lot of software development happens in Unix-like operating systems. Unix-like operating systems. And back in the day, I don't know, like the 60s or 70s, I'm not a historian, there were people who were creating computers, and each computer had a different, not each computer had a different operating system, but all these people in different research laboratories, in different organizations, in different universities would develop their computer, large mainframe, take up the whole room basically, and they would have all these different operating systems. So it's not like today where we have 3 core operating systems: Windows, Mac, and Linux. There's all these different operating systems. And there was one that was rather popular that came out of, if I recall, Berkeley, California, called Unix. And I forgot what Unix stands for. Unified something, doesn't matter. It doesn't quite matter. Called Unix. And it was very popular. And there's lots of philosophies that center around Unix. And one of those philosophies is when you have a tool or some sort of program should do one thing, it should do one thing well. That's sort of a Unix philosophy. We try to carry that over. I try to do that as much as best. Have one tool, and one tool do it best. So we had Unix, and it was rather popular, but it was closed source. It was closed sourced. So then we had a guy come along named Linus Torvald, I believe is his last name. And he wanted to replicate Unix. He wanted to replicate Unix, and he wanted to do it as open source. In other words, that anyone have access to the source code of the program, so anyone can take the source code and modify it and have a better version. The whole idea of having open source software, which is a whole other debate, but he wanted to have an open source version of Unix. And eventually he came up with what's called the Linux kernel. So you can think of it, Linux comes from his name, Linus, and he was trying to port Unix, so he came up with the Linux kernel. And what a kernel is, you can think of the kernel as the core part of an operating system. You can think of the operating system, having the kernel, then it has what's called the shell, the kernel, and then we have all these different applications. Inside the kernel, you also have hardware. I didn't draw it there, but you have your hardware. The kernel is the part that is able to communicate with the hardware. Think of RAM, think of disk, think of the monitor and keyboard. The shell is the layer in which we can communicate with the kernel. If we can communicate with the kernel, then we can tell the kernel to do certain things with the hardware of the computer. And then to round everything up, there are applications. Programs like to read text files, to edit text files, to display graphics, whatnot, all those applications. Packages them all together, and that is an operating system. And this right here, so we have the Linux kernel, but then there was an effort going on by a man named Richard Stallman. And he was also big into open source. He was big into the idea of having code freely available, the source code freely available, so anyone can take it and improve on it. And we also know if the source code is open, then we know what it's doing. So there's no kind of hiddenness to the software, right? No backdoor in which some sort of government agency can have access to. Right, that's the philosophy. I'm not here to promote one thing or the other, but he strongly believes in open source. And he started the GNU Foundation. The GNU, he started the Open Source Software Foundation. And one of those projects was GNU. And with GNU, he was trying to have an open source operating system, but he and his team created a lot of applications that were useful in having Linux become an operating system. Linux is just a kernel. If you want to be pedantic, if you want to be those people who say, the actual thing part is that Linux is just a kernel, but with Linux and GNU, all additional applications can be brought together to have an operating system. So we have Linux kernel plus GNU, and we have this open source operating system that is great because, it's open source. We know how it works. We have teams of people working and developing and improving the Linux kernel. We can also not have to pay a license. So if we're going to have multiple machines host some sort of application, then maybe it makes sense we use an open source operating system so we don't have to pay a licensing fee. So a lot of the servers that power the internet are run on Linux. And when we hear the phrase a Unix-like operating system, Mac OS is a type of Unix-based operating system. It uses the Darwin kernel or something. I have to check. I'm not a historian. But it inherits a lot of philosophy behind Unix. So oftentimes Mac OS and Linux OS, you refer them to called as Unix-like operating systems. I see Edward saying, what tools do scientists analysis use to predict U.S. election results? Well, we can talk about that. Election results, tools for the U.S. And in short, a lot of use Bayes' theorem. Okay, but we can talk a little discussion about that too. All right. So my point here is that a lot of software development happens in Unix-like operating systems. So it's very important for us to be comfortable working in a Unix environment. I've been working in a Unix-like operating system. I've been using Linux since 2008, I believe. So close to 12 years, or pushing 12 years, if I do my math correctly. So I quite feel at home at Linux. So in fact, this pod that we are running, that we have access to, is run on a Linux operating system. So that is why it's important we get comfortable with working with a Unix-like environment. A Linux environment, Unix-like operating system. I've done plenty of talking right now, so let me know if you have any follow-ups, anything you want to bring up about this discussion here, and I can go ahead and talk about tools data scientists use to predict U.S. election results. What is the advantage of Linux over Windows for data science? The advantage of Linux over Windows in data science is the fact that if I if I went to work on a server, that server will probably be running Linux. In fact, AWS, right, and which is what the service we are using, Amazon Web Service, that we are using to enable you guys to have access to accounts, Jupyter Hub, it's running Linux. So if we know how to work in a Linux environment, then we can work on a cluster. We can use those cloud services. If we are comfortable working in Linux and we create some sort of application, it's very for us to easy to deploy that application to some sort of service because it's probably running Linux. So you can think of the infrastructure behind you, since it runs on Linux primarily. It's helpful to understand, have you familiar with the Linux environment. Let's see. So yeah, so be able to use those cloud providers is a great importance. So if you have to run a very complicated process, a very complicated job using large data sets, you have to talk about distributed computing. You might have to set up a distributed computing cluster to run this distributed computing job, and that cluster will be running Linux. For these web applications, probably running Linux more than likely, so I can advantage there, +1 for Linux there. How can we use Linux then easily on a PC? There are two different options. Well, there's probably more. There is one where you take your hard disk and you create a partition. You partition this hard drive. And in this partitioning hard drive, when you partition this hard drive, you say this section here is for Windows, and this section here is for Linux. And that's Linux mascot is a penguin, and that's my picture of a penguin. So you can do this here. So when you start up your computer, you get a prompt that is saying, do you want to boot to Windows? Do you want to boot to Linux? There is also a virtual machine. So you're able to have, this here is a little bit more permanent in the sense that, well, it's not completely permanent, but it's a little more devotion because you are telling your hard drive, you are saying that part of it is for Windows, part of it is for Linux. So you have to lose some hard disk space. There's a virtual machine where you can run Linux within the Windows environment. So there's like VirtualBox is a popular one. There's also Docker, which we can talk about some other time in office hours. All right. Let's see. Someone's saying you can run Linux Bash Shell on Windows 10. Okay, that's good to know. I wasn't unaware of that, but glad to hear. Is it possible to run Linux OS on Windows machine that has less than 4 gigabytes using virtual machine? It is. It should be. Linux tends to be lighter weight than Windows. But 2 gigabytes. I'm not sure what the... You could do something where you devote 1 gigabyte to your Linux virtual machine and 3 gigabytes are left for your Windows. I don't know what are Windows RAM requirements these days, memory requirements, but that you might get away with it. It might be pushing it. I'm not sure what Windows is asking these days. The other thing you could do is you can install Linux on a thumb drive. And you can boot to the thumb drive. And thumb drives are pretty cheap these days. You can get thumb drives like, I don't know, I haven't checked last time, but maybe at least 64 gigabytes, which is plenty for running a Linux operating system. So that's something else you can do as well. Okay. All right. I see quite a few things happening in the chat. All right, so that's a little introduction into Linux and Windows. I'm going to go ahead and talk about, trying to balance a couple of things here, but I do want to revisit this and start working with the command line. I do want to talk about predicting elections. So one of the things people do is, there is a popular website in the US called 538. It's a bit of an unusual name, and why 538? Well, because there are 538 electoral votes in the U.S. Wait, no, that's not true. There are 538. There are 538. Yes, no, that's true. There are 538 electoral votes in the U.S. That is correct. That is why the winner of the presidential campaign needs to get 270. So this is run by someone named Nate Silver, and he wrote a good book. So if you're looking to read a good book, there is. He wrote a book, and it's on my bookshelf, and I see it, but it's too far away. The Signal and the Noise. It's called The Signal and the Noise. So if you want a good data science book, you can read Signal and the Noise. And one of the things he talks about there is the idea of Bayes' theorem. And the idea of Bayes' theorem, and the reason why he was able to be so successful in his predictions, well, he uses the idea of Bayes' theorem. And while he was wrong in the 2016, predicting 2016 presidential election, I believe his final probability was that Trump had a 1/3 chance of winning. I believe that's what came out, 1/3 or 1/4. And that's like flipping 2 coins and getting heads. Right? That's, while it's unlikely, it's quite very much possible. So while he was wrong, he was, quote, less wrong, if I can use that, than other news organizations and whatnot. And one of his he builds upon is Bayes' theorem. And Bayes' theorem is all about how can I have some prior belief. I have some prior belief in a process. And then if I see more data, I'm going to update my prior belief based upon that new data. So he based upon a lot of his analysis on Bayes' theorem. And a lot of it is aggregating lots of things he did was aggregate and know how to best aggregate polling data. And polling data is not the best, but it's better than anything. And one of the things that we observe is if the idea of wisdom of the crowds, the whole idea to aggregate various polls, figure out which one's the best weight for their final prediction. The other thing we could do is when we're trying to project a state, so let's say we're trying to project, let's say this is state of Texas. Oof, that's a pretty bad picture of Texas. That's a little better picture of the Lone Star State there. I'll even throw in a star right there. All right. The other thing we could do is while we're getting vote informations for various counties and various cities, what we could do is, let's say one candidate is ahead of another candidate by so many votes. But we know that what fraction of the votes have come in, it's not uniform across the state. So we know the vote counts in certain regions pretty well because those votes came in and they're being counted. But other regions, we're still waiting for more votes. So let's say in this part of Texas, we only have half the votes, left. One thing we could do is we could, from 2016, understand what fraction of the votes went for one party over the other. And then we can project saying, okay, if it were to roughly stay the same, which is a good estimate, not always true, but it's better than nothing, then we can project how many more votes would one candidate get over the other. So we're able to project. Or if we assume that it's a uniform sampling within a county, and we got, let's say it's 45 for one candidate over 55 over another candidate, then we can say we can use that same projection and figure out what is on estimate the new tally. What's happening here in the US is that there are a lot of votes that need to be counted because they came from the mail. And one thing they could do is they could figure out from the ones that come in what fraction went for one party over the other, and then extrapolate with the other remaining votes. So it's quite a lot of stuff they do, but it's a lot of statistics, it's a lot of aggregating polls, and a lot of using Bayes' theorem. So do let me know if there's any follow-ups right there. Okay, let's see what else people are putting in here. Someone's saying how to start a state-of-the-art report, how to best learn the math and machine learning. I have a background in finance, so that part is ticked. Let's see. Yeah, interviewees aren't always straightforward. That is correct. Yeah, and I think we're understanding that polls aren't not as a good predictor as before. All right, so reading this data, where to start? I mean, it's how to learn the math and machine learning. What I would advise is, this is kind of a crude method, but as you read those papers, start having a list of topics that keep on being brought up that you're having trouble understanding. So maybe they're bringing up some mathematical concept throughout a lot. Then make a note of it. Make a note of how many times it comes up, and then you can come up across a prioritization list, saying, okay, these topics are often brought up. Perhaps that should be my plan of attack or my study. I will have to say, to knock down deep learning has a lot of impressive applications, but sometimes it's a bit of overkill, a little too much. But yeah, I don't know. I don't know how to quite best give you that advice of how to best learn the math and the ML. go Unit 2, right? Beyond Unit 2. Practice and just go through those topics and figure out what keeps on popping up. And yeah. What tool to use for drawing up architectures? I don't use any particular tool for drawing architecture, so I'll be able to give you advice there. How to best get top papers in the domain? Yeah, and I don't know how to best answer that. I am a practitioner. I am not someone who is contributing to the edge of research. So I'm not in the research space of machine learning. So unfortunately, I can't give you any more advice beyond what I've said. Okay. Let's see. All right, so that was a lot of talk. Let's keep on going. All right, so let's go ahead and work with the command line. So I'm going to go ahead and to do that in your pod, you go New Terminal. And what we have here, we have the command line. A couple of things to get comfortable with in the command line is we can type. Well, let me just explain this. You'll see this here. This is your username. And this is the name of the computer. So the name of the computer is, in this case, Jupyter/special admin. And Jovian is just the name of the user. The user at the name of the computer. Kind of makes sense, right? User at the computer. Colon. You see that tilde? That there is a shortcut for your home directory. If I type in ls, what I see is ls stands for list the contents of where I'm at. Want to know where you are? You can say %p. You can say echo pwd. An echo is a command in the command line to display the contents. And the way you identify variables in bash, and bash is the shell we are using, in other words, the way we're communicating with the kernel, is you have them begin with a $sign. So this here is going to show where we currently are. So what we see here is that we are currently in a directory called home and a directory called Jovian. And in fact, that tilde is a shortcut for letting us know that we are in our home directory. So we just see the tilde, that's a shorthand saying of /home/our username. So let's say I want to navigate to a directory. I'm going to say cd data course. And I hit enter. So cd stands for change directory. Change the directory to data course. And notice right there, notice this here tells me where I am. I am tilde. Tilde stands for /home/ the username Jovian /data course. Notice the way you separate directories in a Unix-like operating system is a / as opposed to a \. A little different from Windows. And we can say echo pwd, and it says, hey, sure enough, we are at home /Jovian /data course. Let's type in ls to see what is in here. and we see a data wrangling this file, Python, another file directory called Python, and the update module script. Type in ls, list of contents. Let's say I want to go into Python. So I cd Python. I hit enter. Now I can type in ls to see what's in here, and notice I see all the mini projects along with some additional directories. So the two things that I'm using primarily is cd, change directory, ls, list the contents. Any questions so far as I navigate on my computer, as I navigate this server? Is there a difference between Linux commands and Hadoop file system commands? The answer is probably not so much. And the reason why is because a lot of those other programs, they're probably used to, they create their API based upon Linux. And the whole point here is that people who are comfortable with Linux should be able to be comfortable enough working in a different environment. So there's probably not much of a difference. There might be some differences, but there's not so much, and that's on purpose, right? If you want to make sure people are able to follow along, let's just copy from what Linux does. I have a question here is how do you get list in Windows? And I don't know. Unfortunately, I rarely use Windows, and I don't know what the equivalent of those are. But Linux to Windows commands. I guess it's dir. I can go ahead and put that. Okay. So we know how to check with the contents, how to change directories. Let's say we want to display the contents of a file. So there's several ways to go about that, but I can say cat and say cat, and let's say some file. Specify what standard output should be. It's the screen. Something that's helpful is you can use Control L. Control L clears your screen. You can also do clear as well. So you just type go on, the screen gets cluttered. Control L clears the screen, or clear, that clears your screen. So in other words, you type in ls and then cat, say data course, and say Python, and say cat algorithms, and you want to clear the screen, either clear or Control L. Now notice how I was typing rather fast. And it's not because I type fast. I probably type on average. It's because I'm using tab autocomplete. Just like we have tab autocomplete on Jupyter Notebook, well, guess where it got its idea from? It's got its idea from Bash, from the shell. I'm not sure if the Bash came up with it first, but we're using tab autocomplete. So please use tab autocomplete. Makes your life a lot easier, minimizes typos. Great resource. I can say head, and head by default returns the top, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the top 10 lines of a file. There's head, and there's tail. You can imagine where a pandas got inspired. Remember, there's head and tail methods of data frames. Not surprisingly, it probably got this from the command line. The whole idea is let's call it something that people are used to. By default is the first 10 lines. However, what if we want to specify a different number of lines? So head and tail are great because maybe you don't want to see the entire content of the file because that will flood your screen. Let's look at the top 5, the top 10, bottom 10. But what if I want to look a little bit more? In other words, if I say head in my file, I say, hey, I want to see a little more here. Well, I can specify the number of lines I want to see. So I want to see 20. I say head -n 20 and the file. So here we are able to give what are called options, set options for a command. And the way we set options is we give the option name, we do dash and the option name. So n represents the number of lines I want to display. And this is what this means for this program. N might mean something different for another program. So keep that in mind. So if I say dash n 100, well, it shows me 100 lines. Now, you might be wondering, okay, do I need to memorize all these options? The answer is no, I don't have these memorized. I can Google them, of course. But before the days of Google, what people would do is a lot of these commands have a nice little help option. So if I say head, and I say, what was that option for me to control the number of lines? I can say head -- help. A lot of commands have an option called help. And the way to invoke it is I say -- help. And when I run it, what I get is a nice little usage information. So notice what it says here. It says how to use it. It's head, options, and then the file. Then I say here that information -n. -n followed by the number. So that's how I control the number of lines. Or I could have done -- lines. So notice I have information on how this command works. I see that someone is asking me, does Bash's cat support a file format? And the interesting thing is file formats are arbitrary. Sorry, file extensions are arbitrary. So what cat does is cat displays, if it's a human, you use cat for any file that is human readable. In other words, is it a text file? Doesn't have to end in a txt file extension. Is it a file that is human readable? So the notebook files are human readable. They're just JSONs. So that's why I was able to do cat on those notebook files. If I want a little more information, notice head, I want a little more information, I can use man. I can say man and the command. And man is short for manual. So this will show me a little more longer information. Man command not found. Is there no man? I thought there was man here. Man, let's see, man cat. Interesting. Well, that undercut what I was going to say. What I was going to say is that there should be, if you say man in the command, should give you a little more information about that program. Galo, let me know if that answered your question about the file formats it supports. As long as it's a human readable text, human readable file, cat can read it. Okay. So let's see. All right, and okay. If I want to find, let's say, another useful command is grep. And grep stands for Global Regular Expression Print. Grep is a way to find some pattern in a file. So let's say I want to find all the times I've encountered, every time I have Python in a notebook file. So I can say grep, I specify the what I'm looking for, Python, and the name of the file. And here it's going to print out to me all the lines that had the word Python. So Python, bingo. What else? And Python and Python. So it returns to me the number of lines, the lines that found that pattern Python. And notice how the output was displayed to the screen. But what if the output I want to be the input to another command? In other words, I want to pipe the output here to another command. And the way I do that is by a vertical line. That's called a pipe. Remember we talked about standard input, standard output briefly? These are channels you can view. And by default, it's going to accept input from the keyboard, and it's going to return output to the screen. But what I can do here is I'm going to pipe this output, which was to the screen, and have it become the input, the standard input, to another command. So I'm going to run it, pass it to a command called WC, which stands for word counting. I give the /l option, which is number of lines. So there was 3 lines here. If I want to see a little more about how WC works, I can figure out the number of characters. So I could have piped it to /m. So 473 characters were in this output right here. So the message is I am able to redirect the output of a command as the input of another. And you can have multiple pipings. I can have this piped to something else. You can have it piped to command less. And less is a program that opens up, which allows me to view a file. So the possibilities are endless. Let me know if there are any questions. I think we've talked good enough about the shell and working in the command line, but do let me know if there are any questions before we, and the whole point here is because I plan to next week talk about Git and version control with Git, and that's going to be done through the command line. So I wanted to have this introduction. Sorry to go out of today's scope, but we want to generate a list from one list comprehensions. For example, odd if, okay, yeah, no problem. We can talk about that. So let me look at that Carlos question. And sorry to go out of today's scope, but how do we generate, do we generate lists from one's list comprehension? For example, let's see, for I in range of n. So, Thakalo, are you trying to do multiple list comprehensions. Perhaps let me know what you're trying to do, and maybe there's a solution we can come up with. You could have nested list comprehensions. For example, you could have saying something like for x in, and have this for I in range of n, which is a little weird because range is an iterable, so I'm not sure why you would do this. But you could have a nest. You can have comprehensions with nested structures. Maybe for I, you can say square. How about that? It's a little more makes more sense there. Two separate lists from one list comprehension. So you could do for I in this here, and then before, say, for x in here, you can say for I, for j in range of x, you can say j plus 1. Let's see. I thought you'd be for forgetting something there. For x in there, for I n. Doesn't know what n is because, well, of course not. I could do that. I can have nested list comprehensions. I'm not sure if that's what you're trying to do. So, yeah, let me know if that. I'm not really sure what you're trying to do. But if I see your example, let me try to understand. I don't think so if I understand what you're doing. But you could have nested list comprehensions, and you could always create a list and then iterate through it again. Okay. Any questions about working with the command line before we start with Git? Hopefully my pod will be working so we can wrap up Q6. I was really hoping to wrap up Q6 today so we can start off with something different, fresh and different on Monday. All right, so we'll start planting the seed of what we want to do next. And what I want to do is I want to be able to take what we've done in the mini project and package it into a Python file. And what I'm going to do is I want to create a program that I can run in the command line by saying Python my program. Of course, it will have a more readable name, and then a file. And I want this to do is I want this, my program is going to read a file, and these file here would be the prescription data set we've been working on for the past couple of weeks, and apply that data analysis that we've been working on in the mini project so that it returns a CSV file on our computer that has a list of practices that have been flagged for perhaps some sort of suspicious behavior. This will be a command line tool that we're going to work on. So we'll talk about how we can package this into a Python file that could be run through the command line. And if I can have something that runs the command line, I can have this programmatically run every so often. There is something called cron. I guess cron isn't installed here. We must have, well, I guess it makes sense. We have a little lightweight server for y'all, so we can have as many people on it. But with a script, there's ways in Linux, and I think on Windows as well, where I can automate a process. I can have a process occur, every hour, every minute, or once a day, or once a week, or something like that. So another thing, as we build this file, we're going to keep track of the progress in this project using version control. So that's what we have something to look forward to next week. But do let me know if there's any follow-ups. I think we've planted some of the seeds, some of the preliminary stuff we need to work on this project here. And of course, we'll expand to other projects. I do want to do a web application that we can deploy. Right, that's what I've been saying that since week 1. So let's that is still my intention. All right, time is up here. So with that said, Joseph, you can find me on LinkedIn. Go for it. I just do ask that you tell me that I know you from WorldQuant, because I get a lot of requests. I'm not sure, some of these people I don't recall their names. So if you do connect me on LinkedIn, I do ask that you say, hey, I'm from WorldQuant, so I know, oh yeah, that's Joseph from WorldQuant. That'd be helpful. And let's see. There you go. There's my profile. That should be it. But I do send me a message. Hey, I'm from WorldQuant. I get too many requests from people I don't know. That's the problem. All right. So hopefully next week we'll wrap up Q6 when my pod is back and running, and then we'll create a Python package to do the data analysis, and then we'll branch off to additional projects, additional topics that I do want to hit upon. So that's it, guys. Take care. Have a good rest of your day. Have a good Friday and weekend, and we will see you on Monday when we start doing things outside of the mini project.